So in this data set we are having primarily two cases. Let me remove this class which is already there. This time I'm looking for creating my own class. So driver ID is not required. I am removing this also. So I'm having two features with me, distance feature and speed feature. Based on this I need to make a groups. I'll save it. It's a CSV file. Okay, good to go. So let me start my program. So let me import my dataset first. Read CSV. That is eDrive dataset. Then I have driver data.csv. Let me hold into df. Then I'll take two values. That's good to go. So we are having data with us. Then we can take a call. So before going to into the this prediction part, let me plot this. Let me see whether what the data value. matplotlib.py plot as plt.scatter. So let me take first distance feature. Second, I take speed feature. So I label it existing data. plt.legend, plt.show. That's my data points to which I am looking for. So I have to make a let's start with the two cluster only. So I have to make two group of these data points, and I have to make sure that the centroids are there with us to represent the actual data points. Fine, let's go ahead with making groups. For that we are saying we, in our case, y is not there, so we are going with the x only. So let me take x. That is nothing but your complete data set, or you can write df also, or to be very precise, let me write speed, or let me take first distance feature. Let me copy the name of the columns. So first the distance feature, then speed feature. So I got this same value which is in data frame. I intentionally did this because there is a reason behind this. We will be adding some few columns also in future. So for that I say from Sklearn clusters import KMeans. K and M is capital, then means. I'll say any instance you named it. I'll name it KMean. Then we are having option of specifying clusters. So in that case I'll go for, I'll say cluster. In my case I'll go for two clusters only. That's a case. So I'll say then I go for fit. So under fit we are saying let me have only my x. I will not be having y this time. That's good to go. Complete. So I say now predict. I am creating one column, say group, or let me have a class name km.predict. Based on x, I want prediction should be done. So that is done. See. So if you see class value.counts. So in group first we are in 3200, then group 2 we are in 800. So let's see if they are physically together. For that let me use this chart again for plotting the difference. So I say for A in class, I'll say unique. I'll say df1, df class which is a part of loop with A. I'll run it. I'll say df1. Here rather than labels we are showing the group number. I'll say group plus I'm converting to str which is A. Let's see. So first group which is carrying of 3200 values are this one, and second group is carrying which is around 800 units are this one. So that's a case available with us, which helping us to modify based on our requirement. We can check whether which centroid is there. So for that purpose, for getting centroids, we do have centroid case with us, so we can retrieve the centroid if and when required. So let me go with the 2 centroid case along with the 3 also. So first we are taking 2 centroid. For that purpose only, let me see what is the centroid location. Km dot centroids. Or these are my centroids. So if I plot this value on my graph, I would be getting some points which would be look like physically in say center position of a group. Center position of group would be depending on this density of the data values. So let's plot this case, then we'll take a value. So let me hold this in AR. So I'll plot this. I'll say PLT scatter. I'll say AR. Row I say if I refer this before going here. So I'll say if I AR. So if I go for AR 0 0, I'll be getting a first position, which is this one. If I go for 1, I'll be getting this one. So this is my first centroid. This is my second centroid. So for I'll be using this system for getting my plotting. So I'll say row would be from our A, which is a group name, and I say X and I say Y. Marker I say let it have a asterisk. I'll say color as black. As size I say let it be little big size. Let's see. So these are my centroids. Because the density of data is high in this location, that's why centroids are coming here. If you take this example for 2 or 3 centroids, in that case 2 centroids already there, I'll go for a function where I put a centroid, and based on centroid I'll be getting the outputs. So for that purpose only I'll say df plot KNN. I'll say here I'm writing centroids k value. So I'll say km equal to k means n cluster, which is given by user, which is k. Then I say fit, this is my x value. Then I'm predicting my class again with the new fitted value based on x. Then after I'm calling this function of plotting, the procedure of plotting would be there inside a function only. So indentation I'm putting it right so that I should not get any problem. So let me call this plot kn. So I'm calling with 2, I'll be getting same output. If I calling with 3, see, say group has been created and with individual centroids. And if I go for 4 group would be get created based on centroids. So this is depending on your requirement, whether if you want to go for 3 cluster, 4 cluster, depending on your case, you can take a call. If you are happy with 2, 3, 4, whatever, based on business case, you take a call how good your groups are. Once you have data in grouped form, it has become now supervised data. Now you can use your KNN to predict your future data values if new values are coming and you being asked to map your new data values with your existing data groups. That